Hello, my name is Greg Crinklaw, and I'm the developer of SkyTools. In this tutorial, we're going to look at using the charts in SkyTools. And there are three different kinds of charts in SkyTools for imaging. The first gives us an overhead sky view. The second gives us a naked eye view. And the third gives us an interactive atlas. The charts in SkyTools, it's important to understand how each of them works and what each of them is designed for so that you can use them appropriately. The biggest mistake people make with SkyTools is they don't use the right chart for the job. They just decide they're going to use the interactive atlas for everything or whatever. But the other charts are there for a reason, so it's a good idea to get to know how to use all of them. The other difference in SkyTools is that it is not a planetarium program. And what that generally means is it doesn't open up with a view of the sky. It instead opens up with some tool, in this case, the target selection tool. Because if you open with a view of the sky, you're just pointing in some random direction or whatever you were looking at last time. The philosophy here is when we open a chart, we're going to be interested in a specific object. So let's start with that object first in a tool like the target selection, and then open the chart with that object centered. So that's generally done via a right click. So I'm going to right click on the black eye galaxy here, and I'm going to go down and open an overhead sky chart. So here is our overhead sky chart. The outer dashed line here is actually 0 degrees altitude, but the sky extends beyond that. And that is because this observatory is at altitude, and so refraction allows you to see past what would normally be the horizon down a little bit lower. If you were at sea level, then this and this would pretty much be in the same spot. So what we can do is zoom this in. So I'm going to zoom in. And now what we're looking at is a smaller part of the sky still looking directly overhead. So zenith is always going to stay directly at the head, overhead. And this, by the way, is our black eye galaxy target, indicated by these crosshairs. If I zoom in again, we're now looking more overhead. One more time, now we're looking even more overhead. And in fact, we're not looking overhead, and we're looking overhead so much we lost our galaxy. With time, as I time step, and these are 60-minute time steps, so each time I press this, an hour will go by. This is how the sky will move, and notice that the black eye galaxy is now higher in the sky. So that's generally how this works. It gives us an overhead sky view, and the limiting magnitude of the stars on the chart here is fixed, and it is fixed to represent what you would see to the naked eye. So if you live someplace with a lot of light pollution, you're not going to see as many stars. If you live someplace very dark, you're going to see a lot of stars. So that is the overhead sky chart. And we will talk about these other controls up here when we get to the other charts. Basically, we have a target object, a time, a date, time, location, and the type of chart. I can switch to the other type of charts here. In fact, I'm going to go ahead and do that and switch to the naked eye chart. Now the naked eye chart, I'm going to zoom that out a little bit, is similar to the overhead sky chart, except it shows a sort of wide swath of the sky. And I'm going to press the T key, and that is going to bring up the black eye galaxy target. So just like before, here it is. If I move ahead by 60 minutes, we see that it gets higher. We can see the Milky Way over here, and then it starts to get lower in the sky. And finally, as it's reaching the point where it's setting, the sun comes up and the sky is now blue. So that shows us that this really is a simulation of the sky as it would appear to the naked eye. I'm going to close that. And here's a neat thing that most people don't realize. I can pick a time on the night bar up here, say midnight. I can right click and select Display Overhead Sky Chart. And here's our overhead sky chart for midnight. Kind of handy. So let's say, what's it going to look like at 3 a.m. on the naked eye chart looking south? Here you go. That's what it's going to look like at 3 a.m. For more serious things, we use the interactive atlas. So now I'm going to right click on the black eye galaxy and bring up the interactive atlas. And this is what most imagers are going to use most of the time. So this is the black eye galaxy. I can zoom this in and out. And as I do that, it's going to change the magnitude limit so that we have a relatively constant number of stars on the chart. The black eye galaxy is highlighted with target crosshairs. I can press the T key to make them go away. Press it again to make them come back. There are other ways to change that. If I want to display fainter stars, I can go up here to the mag limit, press the plus button. We go to fainter and fainter stars. As I zoom in, it still remains fairly faint, but it scales with how far zoomed in we are. So these are the zoom controls up here. There are also buttons to do that. We can also click Set and go to a 1 degree, and there we are. I'm just using the scroll bar on the mouse right here to zoom in and out. That's probably the fastest way to do it. We can flip the orientation of the chart left-right by clicking Flip. So that Virgo cluster on the right there is moving, up and down. It moved up and down depending on this button, and it moves left and right depending on the mirror button. So we're going to leave them in standard. We already looked at the magnitude limits, but there's a lot more than just the star magnitude limit. So let's select Set here. And we can put this back to the default. So here's the star magnitude limit. At this zoom level, it's going to be limited to stars that are 8.4 magnitude or brighter, and I can change that. Down here, we have magnitude limits for specific types of objects. So if I put this at 0, it's going to be basically the same as the star magnitude limit. If I put it at -3, it's going to be 3 magnitudes brighter than the star magnitude limit. So instead of 8.9, if I set this to 1, -1, it's going to be only galaxies that are 7.9 magnitude or brighter. If I go the other direction to 1, now it's going to show galaxies down to 9.9 magnitude. And you can choose to set this at a limit that you want, say +7, which in this zoom level takes us to 15th magnitude. I can click this lock, and now it will always show galaxies down to 15.9 magnitude at any zoom level. So I can zoom in and out and will always show galaxies to 16th magnitude. So let's try that. So now we're just seeing tons and tons of galaxies. I'm going to zoom out. We see all those galaxies are still plotted there. So that's something you probably don't want to use all the time. It's best to keep sort of a relative setting, so as you zoom in and out, the chart doesn't get too cluttered. But there's sometimes you're going to want to do that. You can do the same for galaxy groups, and this would be for the brightest, I think it's the third brightest galaxy in your group is what this magnitude limit will apply to. Quasars, planetary nebulae, regular nebulae, that's reflection nebulae, H2 regions. Open clusters, globular clusters, comets, and minor planets. I could set this all the way down here to 23rd magnitude for minor planets and lock this and zoom out, and that's probably a bad idea because that means there's going to be lots and lots of minor planets. At this zoom level, there were only 1, 2, 3, 4, 5. But as I zoom out, there's going to be more and more. It's going to take a long time to draw them. See how long it took there? So you only want to do that if you really want to do that. Normally, I put that it's the same as the star magnitude limit. And now as we zoom in, they will eventually show up if they're bright enough. So that's magnitude limits. The next is time stepping. We sort of saw that a little while ago. You can move ahead by 60 minutes. there's nothing going on here. There aren't any solar system objects, so nothing really changed. I could click this button, and once that's depressed, it will put it into real-time mode, which means it will sync the time to the clock, and it will continue to sync the time to the clock. So it will always show you a view at the current time. Here we have the coordinate system and projection. It is best to leave this at equatorial J2000, but if you have some reason to say I want to put it in the horizon mode, I'm going to zoom out here. It's going to show us where the horizon is. It's not convenient at this moment. So now it's showing us a chart with zenith at the top, and the horizon is in there somewhere. And if I move things, it moves like it would with respect to the horizon. You can do that if you want to. I went to a horizon simulation. Let's move that ahead, and we saw the horizon here briefly, and then it went below the horizon, and there was nothing to see. Okay? But normally you want to keep this at equatorial J2000, which it will have it work like an atlas, and it won't care about the horizon. You could put it in ecliptical and galactic, but it's not going to make a lot of difference on the screen. So let's just leave that in equatorial 2000. The next is the coordinate system projection, and there are various projections here. See how it sort of flipped a little bit when I changed the projection. Things zoom in and out. I'm just going to go to an orthographic and zoom out, and you can see that's an orthographic projection. It's a circle. I could change that to a stereographic. It's a circle too, but it uses a different projection, so things near the horizon are drawn more to scale. Here's an ATOF all sky projection and a cylindrical projection. So this is north up here all the way across. This is south down here all the way across, or at least relative to where we're looking. The best thing to do here is put that on auto, and as you zoom in, it will switch projections depending on your zoom level. And if you zoom all the way out, it'll go to the ATOF, which is the best for showing the entire sky, not just overhead, but the entire sky is here. So I would just leave that on auto. You can save a scenario. So let's say I'm looking at a planet. Let's find a planet. Let's look at Jupiter. You gotta spell it right, or at least close. Okay, so here's Jupiter. I'm going to zoom in, and there's Jupiter and its moons, right? And so Ganymede, Io, other moons are there. Turn off the target crosshairs. So let's say I've got, well, right now we've got Europa with the shadow on the moon, on Jupiter. So let's say I wanted to save that so I could come back to it later. That's what a scenario would be for. I would type in the name for a scenario here, Europa shadow, and I would click save and close. And then I can bring up this scenario again. If there's more than one here, I could select different ones, but we only entered one. I could click open selection, and it's going to bring the chart right back to where we were, what's targeted at the center, and the same date and time. We can trail things. Let's zoom out here. We've got field of view indicators there, sort of making things ugly. Let's switch to a comet. So I'm going to close the interactive atlas, and I'm going to open the current comets observing list, or target list. And we've got too many filters enabled. Here we go. We're going to pick a target that is at least up. Here's one. How did I know it was up? Well, I was looking up here. So here's your imaging quality, high imaging quality, but it also, if you look at this red dashed line, that's the altitude of the object. At the beginning of the night, it's up really high. So I'm going to open that in the atlas. Here it is, a representation of that comet. If I move ahead in time we're going to move. All right. I can set a trail for all comets, or maybe just the target object, and I'm going to trail for 10 hours. All right. And there we go. This is the motion of that object over those 10 hours. Turn that off. I could also set a trace. This can be really useful. A lot of people don't use this, but let's say I want 3 positions, each at an interval of a single day. So I click generate, and now we've added 2 more positions for our comet. And when we come back, the comet is plotted a day earlier and a day later. And we can force it to plot it at a specific time or whatever. This is a great way to know where your comet is going to be from night to night or week to week or whatever you want. So that's traces, and it's for solar system objects. Cleared that. We can print the chart. We can copy it to the clipboard. Here's where you get help. Now we get to the chart controls, and these are available for all types of charts, although the shortcuts aren't necessarily available. Here are the shortcuts for the stars. So do we want to display supernovae, novae? Didn't make much difference here because there weren't any on this particular chart, but now those are enabled from the database. DS means deep sky, so I can turn off galaxies. Oops, there they went. Turn them back on. MSS stands for major solar system objects, so we can turn on the sun, moon, planets, and so forth. This is minor bodies, MB. So this is where you do comets and minor planets. And for minor planets, you can view just certain ones. If you just want to chart centaurs, then you would just check this one, and it will only show centaurs on the chart. Labels. So this tells us what kinds of things are labeled. Let's turn off the labels for deep sky objects, and boom, they're gone. All right, put them back on. Now, all of these are just subsets of the full view controls. And to get to those, you press the All button. So here is all of the things that control what we see. So we can turn galaxies on and off here. Major solar system objects, we can turn that crosshair on and off. Milky Way outline, the horizon lines, various lines. We can add a grid. So let's put a horizon grid line on here. If there's a horizon grid, ecliptical, J2000, etc. We can download background images to display in the background, maybe a digital sky survey image. We put those in a folder. We choose the folder we want, and then we say draw image, and whatever images are in that folder are going to be displayed in the background on the chart. So you could have a folder for globular star cluster images, and if you enable draw image and select your globular star cluster folder, then when you zoom in on globular star clusters, they will all be there in terms of a digital sky survey image. So that's the basics here. Labels. What things do you want to have labeled? And you can do major groups here, just all deep sky objects, all major solar system objects. Turn all the labels on and off. But over here you've got a lot of control. So by type of object, let's pick galaxies. This is the kind of designations that are available for galaxies. Now, let's say you really prefer the NGC. You don't really like Messier numbers. You can turn them off. So now galaxies with Messier numbers, that's not going to appear. It's going to show the common name and then the NGC. Well, wait, I don't like common names either, so we'll just show the NGCs, or maybe just the ICs or the Herschels. I eliminated so many that these galaxies over here are now showing up with other designations beyond the NGC. If I put the NGC back, we've got that. So we can select what type of designations show up. And the way this works is it's a hierarchy. So if it has a common name, and this is checked, it's going to use the common name. If it has a Messier name and no common name, and this is checked, then it's going to use the Messier and on down. But we can change the order. I select Messier. Let's say I really like Messier and I don't like common names. I can move Messier to the top. So if it has a Messier, it will always label it with the Messier. If it has a common name, after that, it'll use the common name and then the NGC and the IC and so forth. So you have complete control over what labels are used for a given type of object. And down here, there's some additional things you can put. Label of designation. If you turn that off, then the designations aren't there at all for galaxies. Here's the label density. At a normal label density, this keeps it from getting too cluttered. If you put very sparse, then it will only label some of the more major galaxies. Notice that it's ignoring these. If you put all, it will label every galaxy on the chart. Right? Let's leave that at normal. So that's how the labeling works. And depending on the chart, there can be other properties. This is the direction indicator down here. I can turn it on or off, or orient it with the horizon if I want. Z is zenith, L is left. So if you're standing there looking, we'll leave that for equatorial. So that's what we call the view controls, and that controls what's displayed, what's labeled, and how those displays and labels work. The next type of control is the chart preferences, and chart preferences determine how the chart looks. So rather than turning things on and off and controlling labels, this will determine the colors of things, how they're drawn, and what fonts the labels use, and so forth. So there's a lot here. You can really customize the charts. And then we can save these as preference schemes. So I'm going to select the astrometry and click apply, and you see we have now a completely different kind of chart. Go back to the atlas and apply, and now we're back to where we were before. So you can create your own types of charts. And it starts with this basic style here and how the stars are drawn. Now this uses a model point spread function, which is what we're seeing here. We can select classic atlas, and now we just have round stars. I've given them a color, but I could make them white. Okay. The background can be white, it can be black, it can be an approximation of the sky color at this time from this location, and that can be a simple sky color that is the same all across the chart, or it can be a complex sky color that is going to depend on where you're pointed. And if you want it to be more blue, you can pick that. But we're going to go back to our model PSF on a black background. There is where we were before. We could also have bitmap stars, by the way, so let's look at those and change the bitmap. There's only one available right now, but the stars have changed how they're drawn. I'm going to go back to the model PSF. Each of these has a different look and a different feel and different purpose, so feel free to play around with it. This controls how the stars are drawn in terms of how big they are. So I'm going to move this slider over to the right, and now we have really big stars. I move the slider down to the left, we have really small stars. If on your printer, for instance, because there's a similar controls for printed charts, if the smallest stars are too small, you can make the smallest stars bigger to make them more visible. Put that back sort of in the middle. And for the classic atlas stars, we can have a line drawn through variable stars, double stars. We can have concentric circles telling us about the different magnitude of variable stars, like you would see on an atlas. You can do that if you're using the classic atlas star style. And you can also, depending on your star style, draw them with a linear increase or logarithmic Again, it depends on what you're trying to do and how you want your chart to look. Moving on to the miscellaneous. Right now it's drawing objects like these galaxies at their actual size. I could switch that to fixed symbols. So now they're all being drawn as symbols, right? And I could set it to automatically. So now it will draw them at their actual size unless they get too small, in which case it'll switch them over to fixed symbols. Go back to actual size. Same thing with planets. You can control that. If you're looking at a planet with a wide field of view on your chart, you can draw it as a symbol or you can draw it as a star if you want, depending on what kind of look you're going for. When you target the sun, it will automatically download the latest SOHO sun image so you can look at sunspots. You can color that by yellow to yellow if you want. And this controls the quality of the render of the planets. If you have a limited device, maybe an old laptop, and it's running too slow when you're looking at the planets, you can toggle this off and that'll make them run faster. Here we have the different components. So this is where we determine how comets are drawn. Globules, galaxies. Well, let's look at galaxies here for a minute. Notice they're filled in. So I can turn that off and now they're empty. It's just outline. I can change the thickness of the outline. So now it's wider. I can select the color of the outline here. I can, if I click match here, then the inside is going to match the color of the outline that I've selected. Also, if you notice that there's a transparency to this fill here, so stars will show through. You could set that to be very transparent or just not transparent at all, completely opaque, depending on what you want. With galaxies, it's usually a good idea to let the stars shine through, so we like to set that to high transparency, which is about there. Let's go to very transparent or very solid, and you see what's happened. It's completely filled in. So that's nice. And if you want, you don't even have to have this outline here. You can set that to be the same by clicking match, and they'll just be ovals. So there's a lot of options there. Lines and outlines, constellation bounds, Milky Way, the meridian line, horizon line. You can control their thickness and their color. So you can completely customize the charts. Finally, labels. So let's say we wanted to change the color of the label for the comets. I'm going to close this for a second, turn off that. So here's our label for the comets. We go back to preferences and labels, and we select comets. I can change the font. So let's make it bigger. Apply. Now it's bigger. I can change the color. Let's make it darker. There you go. So you can do that with each type of object. So that's the chart preferences. And you could really spend a lot of time on this and come up with charts that look completely unique in the way you want them to look. And then you would type in the name of your look and click save. And now it will always be here in the list, and you can switch back and forth from it. Okay, so that is chart preferences. The last thing is background images. And if we can download a digital sky survey image, let's try to do that right here. I'm going to download one. I've right-clicked on this galaxy. In fact, let's just center the chart. Well, I'm going to drag the chart, and we're going to put that galaxy in the center. I'm going to zoom in a little bit, actually. So let's zoom in some more. Okay, so now I'm going to right-click here and select Get Digital Sky Survey Image. Second generation red looks good. We'll get them from SkyView. The file name will have the name of the galaxy. And we'll just download one that's 4 arc minutes across. Click Get Image. It's going out to the server, the SkyView server, downloading the image. Here's the image. Okay, it's not big or beautiful or whatever, but there it is. I can control how I want it to look. So I'm going to increase the contrast a little here. There we go. And then I close that. And now the image is drawn on the back of the charts. I can turn them off here and just show the outline of the image, turn it off entirely, or show the actual image. We put that image in a folder called My Attachments. I could create a different folder and put digital sky survey images, or my own images for that matter, if they're plate solved, in that folder. And depending on the selection I make here, it will only show images from that folder. So that is digital sky survey images. I think we've covered pretty much everything here. Oh, one last thing. I almost forgot. This is actually a big thing. That is the camera view. So now I've selected the camera view. Our digital sky survey image is in the background there. And what this does is it gives us an estimate of what our actual image is going to look like. And I'm going to go ahead and close that. And you can see that we now have a field of view. This square area is the field of view of the camera. I can grab it and I can rotate it. This here is the field of view of the, not sure why it's doing that, of the guider camera, right? Here's a nice guide star. This isn't actually used to set up imaging. We do that with the imaging project in a very similar process, but it allows us to play around with things and see how they would look. So this is the field of view of the camera. When I click camera, that's what we're seeing. It's rotated just as it appears. These stars with a line through them, those stars are blooming. Okay, so if you don't have an anti-bloom filter and this camera doesn't, these stars are going to bloom. You might get streaks out of them. That's why they're marked that way. This is a 1-minute exposure. If I go to a 10-minute exposure, then we're going to see fainter stars, and more of the stars are now blooming. Okay, and some fainter galaxies showed up too, because this is a true simulation. I say it's a true simulation. I've got it set to ideal conditions. I'm going to go to actual conditions. So now it's going to show us what's going on at the date and time and location on the atlas. Okay, so these two things work together. If I change the date and time, my time step, it's going to change the date and time for this view as well. This chart works very similar to others. It's got all the same view controls and chart preferences and so forth. So you can make it look any way you want. You can flip it by 180 degrees if you want to. Some people need to do that. You can choose the filter that you're simulating. So here's the red filter. And the blue filter probably isn't going to show as many stars. What gain you want, binning, it's all simulated. Now what I like to do is I use a second monitor on my desktop and I put this view on that second monitor. So you can continue to use the two of them together without covering one over the other. And that's pretty much it. You put in your exposure time, and you can use this to center objects if you really want to. And you can always bring it up or close it by clicking the button. I'm going to end by saying one last thing is we targeted an object back on this tool, right? But if we go to the scheduler, this isn't an object, it's an imaging project. So what happens if we target an imaging project in the interactive atlas? Well, in this case, it automatically opens the camera field of view that we have selected for that project. And here is the representation of that camera field of view as it would appear when the project thinks we should be imaging. So this is a more complicated way of viewing things and more information in it if you view an actual project rather than just a target object. So I think that covers everything. Thanks for watching.